Actually, whenever there will be question on bond angle, what you need to do, it's very
Okay.
simple. NH3, PH3, SH3, BiH3. Oh, sorry, SBH3 and then BiH3. What you need to do, just go for hybridization first. If you're going for
Okay.
hybridization, every central atom here will be sp3, right?
Yes. Yeah. Yeah.
So if hybridization will be different, the bond angle can you can easily manipulate that which one is a greater and which one is lesser. But if
Yeah.
the hybridization will same, then go for lone pair. So you can see everyone has one lone pair. You cannot differentiate because
Yeah.
everyone has one lone pair. Now, if
Yes.
this fails, then go for electronegativity of central atom. If electronegativity of central atom is greater, that means bond angle is greater. And if you are seeing the electronegativity of surrounding atom is inversely proportional to bond angle. So if I'm going to ask you a question, which one is more or which one will be highest in bond angle, so this will be the order.
Okay. Okay. Okay.
Okay. If I'm going to ask you, oh, bond angle, calculate the bond angle, basically which one will have more bond angle. You can see first you need to calculate the hybridization, that you will see it is sp3 as well as this is also sp3. Lone pair, if you are going to see, it will be 1 1. But if you are going, when it both fails, then go for electronegativity of central atom. Here electronegativity of central atom is greater and here surrounding atom is greater, that's why bond angle of this is affected.
Yes. Okay.
Got it? Then we move to the next part.
Wait a minute. Let me note down some.
Okay, please do it.
Yeah. Done. Done.
Very good. Now see, we are going to talk about this melting point of group 15, 16 and 17 as well. So the melting point will have basically this BiH3 will have the most melting point, then comes the NH3, after this SBH3, and then here comes ASH3, and the least melting point is pH3. This is the order of melting point. It's very important.
Okay.
BiH3 basically it forms network solid due to its large uh, size network form. That's why it has the more melting point. Then comes your NH3 because there will be hydrogen bonding, and then comes SBH3, and the list is pH3. Is that clear?
Okay.
Now, in case of 16th group, H2O will be most because here the hydrogen bonding is very, very strong. Then comes H2PO, which is metallic and polymer form type, or you can say network form. And then comes tellurium, and then comes selenium, and then the lowest is H2S. And about the, this is your melting point. About the 17th group, this will be the most HI, because you know that molecular weight increases for van der Waals force of attraction increases, right?
Yeah. Yeah.
HF, because hydrogen bonding is will be there as well. So this is the order of melting point of the hydride of group 15, 16 as well as 17.
17. Okay.
Okay, when you are going to talk about boiling point, so For boiling point group 15, follow the order BiH3, metallic form, force of attraction high, SbH3, then comes your NH3, hydrogen bonding, then comes your ASH3, and then comes your pH3 will be at last. Here see, in melting point we see packing, and in boiling point we see force of attraction. So here the packing is better in NH3 as compared to SbH3. That's why SbH3 is behind NH3. But here the force of attraction is more in SbH3 as compared to NH3. That's why. For second, it is for 16, it is H2S, then it is H2Se, selenium, and then it is H2Te, tellurium, and then it is polonium, and then comes your H2O, the highest in boiling point, because the hydrogen bonding present in water is tetrahedron. That means it makes one water molecules makes 4 hydrogen bond. That's
Okay.
and for 17th group, hydrogen fluoride due to hydrogen bonding, then comes Hi, then comes HBr, and then comes HCl. This is on the second number because you can see its atomic weight or molecular weight will be higher, and so the van der Waals force of attraction is also very high. Is that clear?
Yes, yes. Yeah.
Please do it. We already discussed about the oxide of nitrogen, right? Yes or no?
Oxide of nitrogen. Wait.
Just check it. Just write it, then I'll check it.
Yeah. Yeah, done. Yeah, we did. Yeah. Yes. Yeah.
Wait a minute. Let's start this. Types of oxides.
Okay.
Types of oxides. For types of oxides, we have acidic, we have basic oxide, as well as we have neutral oxide, and as well as we have amphoteric oxide. You know what is amphoteric oxide, right?
Yeah.
Amphoteric oxide which can react with acid as well as base, right?
Yeah.
So
Yes.
first of all, you need to remember this list, that is neutral oxide. Okay, oh, I didn't switch it on. Okay, neutral oxide. So neutral oxide is basically very countable. It is 3, and that is NO, nitrogen monoxide, dinitrogen oxide, and CO. These 3 are neutral oxide. Always remember this. Okay.
Okay.
Then comes acidic oxide, and there are some rules to which follow to be acidic oxide. So for acidic oxide, you can see I'm going to write this B2O3. Generally, non-metal oxide are acidic oxide. Generally, non-metal oxides are all the non-metal oxides are acidic oxide except neutral oxide. Are you getting my point?
Okay. Yeah.
SiO2 will be there, NO2, and then comes N2O3, and then N2O5 you have seen, and also there are some more P4, O10, you have seen P4, O6 as well, SO2, SO3, and all oxides of halogen, all oxides of halogen. So we can write that all, non-metal oxides are non-metal oxides are acidic in nature. Acidic in nature except amphoteric, except neutral oxide. Are you getting my point?
Yes.
So please do write up to this. You just need to remember the amphoteric oxide. You just need to remember the amphoteric oxide.
Yeah. Yeah, done.
Then I'm going to give you this list of amphoteric oxide. Amphoteric oxide. See, we did this in acidic oxide. We need to write Mn2O7. This is acidic oxide. We will see how it is acidic oxide, and also basically V2O5, and then comes your CrO3. These are all acidic oxide. Okay.
Okay.
I will tell you why it is. Amphoteric oxide. Amphoteric oxide, you need to take care of BeO, then Al2O3, then Ga2O3, then comes your GeO2, then comes your no, not GeO2, Ga2O3, and then comes SnO2, then comes PbO, then comes PbO2. These are all amphoteric. Then comes your As4O6, then comes your As4O10, then comes your Sb4O6, and then comes Sb4O10, and then comes ZNO, then comes your Cr2O3, then comes TiO, etc. These are all amphoteric oxide.
Yeah.
Okay. Or for basic oxide, you know all the oxides of group S block are
Yeah.
basic. All the oxides of S block except BeO, because this BeO is amphoteric. Except this, all the oxides of S block are basic in nature. Is that clear?
Okay. Yeah.
Now the most important point comes here. Elements form amphoteric. The elements which forms amphoteric oxides are basically zinc, always from aluminum, then lead, always from Be, always from Sn, always from antimony, As, selenium, and then comes gallium, and then comes chromium. Okay.
Okay.
Basically all the elements which form amphoteric oxide. So please do write it.
Yeah, done.
Done. Very good. Now see, for metal, I want to say that for metal is, if there is metal, we know that from childhood that metal oxide is generally basic, but it is not. When the oxidation state of metal is less than 4, then it is basic oxide. Are you getting my point?
Yeah.
Metal oxide, in metal oxide, if the oxidation state of metal is less than 4, then it is basic oxide. If it is equal to, oxidation state equals to 4, then it is amphoteric. And if oxidation state greater than 4, then it is acidic. Exception will be always there, acidic. Are you getting my point? Like this exception, if I'm going to tell you ZNO, so you know that here Zn has +2 oxidation state and it should behave like basic oxide, but I already written it that Zn, the oxide of Zn will always be amphoteric. So this is the list you need to remember for amphoteric list. You already know that the neutral oxide is basically only 3, CO, N2O, and NO. You just need to remember this this what amphoteric, because acidic oxide, all the non-metals are acidic oxide, Now oxide except neutral. Only the difference creates is only because of this metal oxide. Okay.
Okay. Yeah. Yes.
Got it? Can I change the slide? Please do write it. If you are done with this, let me know.
Yeah, done. Yeah.
Very good. Very good. So we also are done with oxo acids of sulfur, right? Or we are not
Yeah,
done
yeah,
with this? We're done with
yeah.
this. Like I'm going to write the name, and it's the questions on this are very easy. If you know, you will get marks. If you don't know, you can't do anything. So I'm going to write the name. Just let me know if you know the formula of the compound, because there are some terms like chirose acid. Do you know what it is? It is also acids of sulfur. Do you know chirose acid?
No.
Okay, no problem. See, you just need to know the formula because you know how to draw the structure. Sulfuric acid. I'm going to write all the oxo acids. Sulfurous acid, and then comes thiosulfuric acid. Then comes thiosulfuric acid. And you are going to make a short notes of this. I think you will
Yeah.
get marks of this. At least one or two questions you will be getting. Then comes pyrosulfuric acid. Pyrosulfuric acid, that is also known as basically oleum. Pyrosulfuric acid, oleum.
Okay.
I'm just going to give you the list. Then I will write the formula as well. The fifth one is basically peroxo. No, peroxosulfuric acid. Sulfuric acid. And this acid is also known as Marshall's acid. Marshall's acid. Wait a minute. Marshall's acid. You know that this formula is H2SO4, and then sulfurous acid has a formula H2SO3. Thiosulfuric acid has a formula H2SO3. Pyrosulfuric acid has a formula that is oleum H2S2O7. And then comes this peroxosulfuric acid or Marshall's acid, right? Marshall's
Yeah.
acid has a formula H2S2O8. And then
Okay.
comes your Carose acid that I told you right now. Carose acid, you know what its formula is H2SO5. Okay,
Okay.
can you change the slide?
Yeah. Yes.
Now come to the next, that is basically the seventh one, that is dithionic acid. Dithionic acid, and it has a formula 2 into H2SO4, 2 into H2SO4 minus H2O2, minus H2O2. And what you will be getting, you will be getting 2 to the 4, then 2 hydrogen is left, then S2 and 2 4 Z, then O6. This is the formula for dithionic acid. Okay, so basically what
Okay.
happens here, basically what you need to do, thionic acid, you need to write the H2SO4 structure like this, and you need to write the H2SO4 structure like this, and you need to remove H2O2, that means this part, and connect this part. Then what you
Oh,
will be getting, you will be getting S double bond O, and then S double bond O, double bond O. Got it?
yes.
Very good. If I'm going to ask you, what is the N factor of this? Can you tell me?
N factor. Wait. Uh,
Two. Because it is acid, it will give 2H plus, so its N factor will be 2.
Okay.
Got it? It's easy.
Yeah.
Very good. Can I change the slide?
Yes, yes. Yeah, yeah, yeah.
You can easily write the structure of this, right?
Yeah,
This
yeah, I
all.
can. Yeah.
Okay. Please make sure you are going to revise it all because actually when I was giving a junior research paper, the question was based upon this Carros acid. And the question is like, how many lone pair present on Carros acid?
Oh, okay.
Thanks to
Yes.
my students that I always or have to repeat many times in 1 year to teach, right?
Yeah, yeah.
Carros acid. So this is the some points that you need to take care of now. Can you do that part like preparation of H2SO4? I think you can do. Let me know. We need to discuss about the syllabus because I'm going through all the concepts. So it will definitely take a lot of time. Are you getting my point, Davis?
Yeah, yeah. Yes, yeah.
So I want you to let me know about the uh, like we need to I need to skip some points that you need that you have to cover that you can cover
Yeah, yeah, yeah.
like
Yeah.
a preparation of this H2SO4. Can you do this by contact process? Contact process will have 3 steps in which you need to convert sulfur into sulfur dioxide, and this sulfur dioxide will be converted into sulfur trioxide with the help of catalyst V2O5. This is just a theory and a laboratory experiment. I think you can understand this,
Yeah, yeah.
right?
Okay, okay.
And
Yeah.
this SO3 will be converted, reacting with H2SO4, then it will be converted into oleum, and this oleum can be converted into H2SO4. So you can do this, right?
Yeah, yeah. Yeah.
So you can also do this that this H2SO4, if you are going to heat it, then what will happen? H2 will be eliminated, and what will be there? SO3, anhydrous form of H2SO4. Then if you are going to
Okay.
react with zinc, which is metal, so zinc is more reactive, so hydrogen will be replaced by zinc. Yes or no?
Oh,
In electrochemistry, we
yeah.
have studied. So this part you have to do on your own. Like if you are going to react with calcium oxide, so you know calcium is more reactive than hydrogen, so it will H2SO4 it is. It will
Yeah, yeah.
replace this and it will form H2O. Then again, if you are going to react this with NaOH, you know that this is acid, this is base, then what it will form? There will be formation of salt plus water.
Salt. Yeah.
If you are going to react this with Na2CO3, sodium carbonate, it is also a salt. So what will be the formation? There will be formation of salt plus H2O, and due to the presence of carbonate ion, there will be formation of carbon dioxide as well. Are you getting my point?
Okay, okay. Yeah, yeah. Yeah.
What you need to take care is that just remember some points of the product the compounds. Like if you are going to study human, like I will give you a project to uh, study the students in my class, study the behavior of the student in my class. If the student are in same class, same section, and if the gender are also same, that doesn't matter that they will show similar property or in all aspect. Are you getting my point?
Yeah, yeah. Yeah. Yes.
So in this way, inorganic is like the study of elements first, then reacting the elements and forming compounds, different compounds. Then you are going to study the compounds. So these compounds will have different properties. It is not necessary that if they belong from the same family or same group, they will show similar. So they will have all the properties similar. They will have, they may have or they may not have. Are you getting my point? So what you
Yeah,
need
yeah.
to take care is that this H2SO4 is basically your oxidizing agent, basically good oxidizing agent. So if you are going to put this H2SO4 in carbon, it will convert into CO2. Okay, if you are
Okay.
going to convert put it into sulfur, it will oxidize it into CO2, then SO2, and this is HBr. It will convert it into Br2 0. Here it is in -1. It will oxidize basically. So you need to take care of this. Sulfur is -2 here. It will oxidize it into 0. Are you getting my
Okay.
point?
Yeah, yeah, yeah. Yes.
Can I change this slide?
Yeah, yeah. Yes.
Very good. So there are some more reaction that you need to take care of, and you also know that this H2SO4 is dehydrating agent. That means basically it will remove water from the molecules. Okay,
Okay. Yeah.
it will dry it off or make it anhydrous. Like if I'm going to react this H2SO4 with sucrose, that is C12H22O11, it will take all the H2O from here, 11H2, and carbon will be in anhydrous. Are you getting my point?
Yeah. Yeah.
If you are going to use concentrated H2SO, concentrated H2SO. If you are going to use this on formic acid or methanoic acid, concentrated H2SO4, then same H2O will be eliminated. So if H2O will be eliminated, only CO2 will be left. You can see H2O, so CO will be left, right?
Yeah. Yeah.
So this is how we deal with this. And also there are a lot of other reactions like H2SO4. If you are going to react this with NaNO3, sodium nitrate, so sodium is more reactive than hydrogen, so it will form NaNO3. Sorry, wait a minute. So it will form one of the hydrogen will be replaced by sodium, so it will be NaHSO4, and you can see one hydrogen is gone from here, so there will be formation of nitric acid HN. Then if you are going to react this with NaCl, which is a salt reacting with acid will give acid plus NaHSO. Then again, if you are going to react this with BaCl2, then BaSO4 is formed because barium is more reactive than hydrogen, and this is basically your white PPT. Okay. So you need to go through NCERT. If you want to score a very good marks in inorganic chemistry, especially, so what you need to do, go through the NCERT. It might be
Yeah.
tough first time to understand, but it's very not that much tough. You can do that. Okay,
Okay.
can I change the slide? If you're going to react this with PbNO3 whole twice, the last reaction of this, then it will be forming PbSO4 white PPT. It is also white PPT. Lead is also more reactive than hydrogen, so it will replace it.
Yeah. Yeah.
Okay.
Okay. Yeah.
Now see, we are going to see about the halides of group 16. Halides of group 16. Halides of group 15, we have already discussed PCl3, PCl5. Halides
Yeah.
of group 16. So you know that it will form either EX6 type or EX4 type. And also it can form EX2 type. Like SF2 is also there. SF6 is also there. SF4 is also there. Halides, we are talking about halides. Monohalide is also possible, monohalide, but it dimerized because in order to stabilize itself, SF dimerizes itself to form S2S, F2 in order to stabilize itself. Is that clear?
Yeah. Yeah. Yeah.
Okay. So first of all, this if I'm going to write the halide of this sulfur, SF4, then SEF4, then TEF4, and then now up to this, you can see this is gas, this is liquid, and this is solid. Why it is so? Down the group, molecular weight increases, van der Waals force of attraction increases, that means converted into solid. Force of attraction increases, that means it is having more force of attraction, so that's why it is in solid state.
Yeah.
Also, it's very important to note that down the group, melting point increases and also boiling point increases here because of size increases or size increases. That means atomic weight increases. That means van der Waals force of attraction also increases. Is that clear?
Yeah. Yeah. Yes. Yeah.
So always keep it in mind. Can you tell me the hybridization of sulfur, hybridization first, and then tell me geometry, and
Okay.
then also tell me the shape.
Yeah, it is
Yeah,
sp3d, and
very good.
it is like
Geometry is
yeah, geometry is
geometry,
trigonal pyramidal. Yeah,
bipyramidal.
okay, bipyramidal. Yeah,
Shape
but one
is
lone pair is there,
seesaw.
right? But okay, seesaw.
Yeah,
Yeah, yeah, yeah, seesaw.
yeah, it is season. Okay.
Yeah,
So this is the halides. And I also told you that this what we call H2F2 monochloride is also possible, but in order to stabilize itself, what it does dimerize. Okay, so always
okay.
remember this. Okay, wait a minute. There are some questions that I had given. So for the oxygen family, we just did for oxygen family this, but you can remember this for sulfur, selenium, polonium. This is oxygen family, and you know that this is in gaseous, gas, and then comes solid, solid, and solid. Because down the group size increases, and that's why the what we call
Van der Waals.
van der
This
Waals
come.
force of attraction increases, and that's why
Yeah,
it happens. Okay. So if
yeah,
you are going to see the oxides of this, then what will be the formation? You know, there will be formation of SO2 as well as SO3. In the same way, SeO3 will form and TeO3 will be there. Okay. So there are
yeah.
some questions that is very important, and uh, for Fajan's rule, it is basically Fajan's rule. Do you know what is Fajan's rule?
Yeah, I forgot, but I know the rule. But,
Yeah, yeah. Fajans rule is according to this basically. We compare the ionic or covalent character of the compounds. Okay. If I'm going
yeah,
to ask you which one is more covalent, what is your answer? PCl5, PCl3. Which one is more covalent?
yeah, no idea.
Okay. So see, basically this Fajans rule, actually we saw compare the ionic or covalent character. So covalent
Yeah,
character, if I will ask you which one will have more covalent character, what you need to do is this covalent character is directly proportional to polarizing power. PP is for polarizing power, and polarizing
yeah,
power directly proportional to inversely proportional to size of cation. Size
yeah,
of cation. Or we can write polarizing power directly proportional to charge on cation. Charge on cation.
yeah,
Because you know that if some cation will have greater charge, that means it will have lesser or smaller size. So you can see it will have +5, it will have +3. So this will have more covalent.
okay,
Are
okay,
you getting my
okay.
point?
Yeah,
Okay.
yeah,
And this I just defined it for covalent. We can go for polarizability. Polarizability is directly proportional to charge on anion
yeah,
and directly proportional to size of anion. Size of anion. You know that if negative charge on some element is greater, that means charge size of that element is greater. Got it?
yes, yeah,
Okay, very good. Now there are some compounds of group 16 that is very important to learn, and that is basically your SO. And SO2 is a reducing agent. Do you know that? It will reduce. So if you
okay,
are going to react this with Fe2 SO3, sorry, SO4 whole thrice, it will convert it into FeSO4. How it is possible? You can see this is your reducing agent. In here it is +3 and here it is +2. So it reduces iron. If you are giving it SnCl2, you can see this is in +3, and now it will be SnCl4. SnCl4.
yeah,
So wait a minute. There is some other point first. Okay. The reducing agent and the another example of reducing agent first is PbO, PbO, and it will be converted into PbSO, PbSO. So basically, SO2 acting as reducing agent, you just saw. Now you will see if you are going to react it with SnCl2, it will be converting into SnCl. Now, if you look at this, it will this is a +2 and this is +2. That means the tin is oxidizes. That means SO2 basically acting as oxidizing agent as well.
Okay.
It has both characters. Are you getting my point? If you are having Hg2Cl2, Hg2Cl2, that means +1 oxidation state here. Here it will be HgCl. Again, it is converting, acting as oxidizing agent. Got it?
Yeah. Yeah.
So see, always remember that the elements, basically every element has some lower oxidation state and higher oxidation state. If it is in lower oxidation state, it wants to go on higher oxidation state. Yes or no?
Yeah.
And if it will go in higher oxidation state, that means oxidation of this element will take place. That means the front as substance, the front whatever is the substance that it is reacting with will be reduced. That's why whenever an element is in lower oxidation state, it will act as a reducing agent. Are you getting my point?
Okay. Yeah.
And whenever an element on in higher oxidation state, it will act as oxidizing agent because it wants to reduce. It will only reduce, not go far from their point. And if it is in between this, it will act as reducing agent as well as oxidizing agent. That clear?
Okay.
So as you can see, sulfur has -2 to +6, and here the sulfur is +4 in between these two. So it can act as reducing agent as well as oxidizing agent. Okay.
Yes. Yeah.
Okay. Very good. Please do write it.
Yeah. Done.
Yes. Very good. Now see. Do you know the structure of ozone? The formula of ozone you already know.
Yeah. O3.
This is O3. O3, and in which the oxygen make a coordinate bond. So this is like this. Okay.
Yeah.
And it is like this. That's why that means this oxygen does not its electron does not participate in bonding. So there will be a resonance. You can do resonance, and due to this resonance, O3 is stable. Okay.
Yeah.
Now this O3 has a lot of other reaction that we need to study. If it will react with Ag, it will form Ag2O. If it will react with Hg, it will form Hg2O. If it will react with I2, it will form HiO3. HiO3. If it will react with P, it is in the presence of basically hydrogen will come. It will react in some solvent. Okay. Okay.
Yeah.
Then with the P4, it will be H3PO4. With acid, it will be reacting with H2SO. With Fe+2, it will convert it into Fe+3, oxidizes it.
Yeah.
And with H2O2, if you are going to react it with H2O2 and heat it, then it will be converted into O2. Okay.
Yeah.
So please do write it, or just remember this. And it's also important to you to see the lecture as well, see the NCRT. Okay.
Yes. Yeah. Yeah, done.
Done.
Yeah.
Very good. So we also done this. Okay. Wait a minute. Okay. Now halogen family. See halogen family. For halogen family, you know that this is fluorine, chlorine, bromine, and then iodine. And these are very important and they are very electronegative. Fluorine is the most electronegative element in the periodic table, and chlorine has the most electron gain enthalpy. Most electron gain enthalpy in the periodic table. Is that clear?
Yeah.
So it's very easy to understand. Before that, I would like to ask you some question. The question is based upon in this question is very important, and it is based upon what we call experiment basically. Brown ring test is used for the identification of PO4 minus 3 is NO3 minus C is SO4 minus 2 D is HCO3 minus. This type of question you will be only able to solve it and you will read your notes or the NCRT. So brown ring test is basically for NO3 minus. Did you know it?
No.
Okay, so you need to revise your notes as well as NCRT. Okay.
Okay. Yeah.
Can I change the slide? Can I change the slide?
Yeah.
Okay. After this chapter, which chapter we are going to cover? White phosphorus.
Yeah. I'll see. Yeah.
Okay. District P4 units. On Sunday, I'm going to make a PDF and then there will be questions on all this P block. And then
Okay.
we are going to solve it. And then wherever you will have doubt in every concept, in every where what I want to say is that whichever question you will have doubt, we will discuss. Okay.
Yeah.
So you are going to read it all. You have notes, right?
Yes. Yeah.
The PPP bond angle is the PPP bond.
Okay.